Hello everyone and welcome back. So this time we're going to talk about vector analysis. So last time we learned how to calculate a moment. It's always that force times some perpendicular distance. And this time we're going to learn how to do that with a vector approach. So, how do we do this? Well, it's not too terribly hard because to get the moment, we just take a cross product. But the important detail here is that cross product, R cross F, is always going to be just the total moment. But a lot of times, especially when we're turning things around an axis, we only care about the moment around that axis. There's a whole lot of wasted stuff that's just eaten up by the stresses inside of the part. It doesn't actually twist in that direction, at least visibly that we can see, because all the stresses in the part prevent it. So let's say in this case right here, we have a position vector R, we have a force vector F. And the important thing to remember is this. Whatever point you care about, you're trying to find the moment about that point. Your position vector starts from there and goes to some point on the line of action of the force. This is a very interesting detail. Your position vector just has to go to the line of action of the force, not to where it's actually applied. So if you know how to get there to a very short distance, maybe there's an easy vector, use it. It's a very helpful detail. You just have to get to the line of action of the force, not to where the force is applied. Also, if you're trying to figure out if it's R cross F or F cross R, the position vector goes to the force, so position vector comes first. Okay, but let's say we want to go only around this A axis here. Okay, we want to figure out what the moment around that A axis is. We know how to take a cross product, but how do we get that component? Well, we get it by taking a dot product with that cross product. This is something called the triple scalar product, as we're going to see. And there we go. So this is the triple scalar product. Now you're like, this looks really complicated. There's a dot product in there. There's a cross product in there. It's honestly not that crazy because you've done this before. You just don't realize it. Anytime you have a vector with I, j, and k components, and you say, I just want the x component. Well, you do this actually. You have done this. You take the dot product of the I unit vector with that vector, and it pops out just the x component. Or the dot product with the j vector, or the dot product with the k vector to get just the y or z components. So you have done this before. It's just now instead of our unit vector being along the x, y, or z axis, it's now along some different axis. Now if you're trying to figure out what order to do this in, make sure you do it, take the moment first, and then take the dot product. Don't try to take the dot product with R and then cross that. You're just going to mess things up. It doesn't work in that order because the dot product gives you a scalar. It just gives you the magnitude of that component that's along this line. The cross product gives you a vector. Remember that. You can take the dot product of two vectors. You cannot take the dot product of a vector and just a single number. And you cannot cross a number with a vector. So remember that. And that's pretty much it for this section. It's really something you just have to practice and see to, I think, truthfully grasp. But it's a very helpful detail. So don't forget it. And as one other little note, if you ever really get confused about this, with the whole A right here, just imagine that you're rotating your axes so that this is now the x-axis. I mean, everything else would change, but just to remind yourself that all you're doing is you're getting the component that is along this direction, and it just happens to be named A. It could have been named X. That could have been the x-axis if we had oriented our coordinate system a little bit differently. Okay, well, I'll stop here. I hope this helps you. And I'll see you all next time as we do a couple examples. Bye-bye.